All right, let's go and take another crack at making this program look a little bit more like functional programming code. So notice here, I recognize an opportunity for us to create a factory function and use closure. So it is possible that, well, I mean, all of these variables are defined in this file. And so any function in this file has access to them and they can potentially update them. And especially like, let's say, for example, something like the next to do ID. It's very easy to mess this up, to accidentally overwrite it. It would be better if we could somehow protect these variables and, not expose them to the elements, so to speak. And so we could put an abstraction on top of it where we can control the basic operations that we want to perform on them. Right. So the way you can do this in a functional programming language is by putting these variables inside, declaring them inside a function, and then only exposing operations from that function that would allow you to access these or modify them. Given that most of you are coming from object-oriented programming languages, this is something very close to the idea of like creating classes, where like these would be the fields, and then we have some operations that operate on these fields. But the somewhat equivalent of creating that kind of information hiding and encapsulation is to use functions and the idea of closure in functional programming languages. So let me show you how that looks like. Let's go and create a function. Let's call this create to do app. Not the greatest name, but anyways, I'm gonna roll with it. Maybe it would have been better named like create to do app state or something like that. But anyway, so all these variables are now inside this function. If I save it, we're not gonna have access to any of these variables. And you see this buy milk and buy bread, not because like I have them in here, because these are hard coded in the HTML of the application. And so now I've got these functions that are operating basically on the to-dos, and I can grab them, cut them out, and dump these inside my create to do app as well. And basically what I want to do at the end of the day is I want to return something like an object that allows me to have some handy functions, things like add to do, right, a toggle to do, and maybe like filter to do, something like this. And the idea is I would go and like create one sort of variable or object, something like a to-do app, using this factory function. And then I would use like the to-do app and these objects on it. Like if I want to, let's say, toggle it to do, I do to-do app dot toggle to do, something like that. And I'll work with this. But before I get there, let me clean this up a little bit more, make sure that what I have here makes sense. Let me go through this sort of step by step. So add to do. Now that I'm sort of here, like within this function, I don't really need to pass the to-dos anymore. It exists here. And so what we can do is we can just let a client give us the to-do text and we'll take care of the rest of it. But I mean, what we're doing is, well, maybe it's good if I just inline this right here, because it's fairly small. So maybe I can just inline it right here. So this is like the key, and here is the value, and the value really is a function, right? So that's the value, and you put a comma there to separate it. And what this value does is that it overrides our to-dos with whatever was the oldest stuff in the to-do and then the newest stuff. And let's put this here. Okay, now this looks good, right? Right, good. And like the next to-do, you know what, let's actually clean this up, because like we don't want to start the app with random to-dos that don't make sense. We want to let people have a blank slate and start writing their to-dos. So this should also be 1. Yeah, and so if you want to add a to-do, you just provide the to-do text and that's it. It will override this. And so this kind of adheres to this idea of immutable data structures. And we can do something similar for the toggle to-dos. Like I can bring that here. right? And I don't really need the to-dos, just give me the to-do ID, and I will then update the to-dos with this new, right, something like this. So go over it, and if the ID is a match, flip or toggle the completed, otherwise just return what it is. Okay, cool. Let's make this a little cleaner, like this. This looks better. Okay, let me take this out, and filter to do. Again, this doesn't really need the to-dos. Return. Okay, you know what I can do? I can, maybe it's nicer if you just call this get to-dos, you know, and it just filters the to-dos. Really, the filter is here too, so you don't need that. So this doesn't override anything that we have here. It just returns a version of the to-dos that is suitable for us to display it based on the value of filter. And on that point, we probably want to get control of setting the filter, right? So like give me a new filter, and I'll go and basically do this. Filter takes the new filter, right? That's what I will do. Let's clean this up a little. And so this looks good. We can now take a look at the rest of the app, see where else we need to make an update. I don't think this needs an update. This is fine too. This one is fine too. Oh, here is the opportunity. So we can say to-do app, get to-dos, and that's it. Then map it to create the to-do items. Now all those to-dos are gone because I started with a empty to-do. So you see it is getting wired up to the rest of the application. Update classes, this doesn't need any changes. This is fine. Oh, adding a to-do. Let's say to-dos app, add to-do, and we just need to, oops, did I call it to-do app? Yes, to-do app, add to-do, and just give it the new code. And this is fine now. This one, filter, we are updating the filter, to-do app, set filter, and then pass it this variable. Okay, event toggle, there we go, to-do app dot toggle to-do, and you just need to pass the to-do ID to it. Okay, that was all of the functions that we had, right? All right, we can wrap this up too. Cool. All right, let's give this a try. Make sure that it all works and we don't have errors. So buy milk, okay. Buy jam, buy bread, buy coffee. So we get a good breakfast. No errors shown. Well, let's keep it up. Let's try a few other things. So let's say we did the milk and a coffee, but these three are left. These are, well, these two are left. These are the active ones. These are the completed ones, and this is all of them. So we got proper refactoring. No bugs were introduced. But let's talk about this a little bit more. So the part that's interesting here is that you call this function, right? And it basically just returns an object to you, right? But what makes it interesting is that when you go and then further work with the object that was returned to you, it seems as if it remembers the variables that are part of the scope of this function, which like normally when you call a function and that function is called and done, all of its local variables should be like wiped off the memory, right? So like the garbage collector should like collect all the to-dos. But it doesn't do that because of what we call closure. So these other functions that are here, and they kind of rely on these local variables, they sort of get a copy or a reference of that variable. And so that's how effectively this object has access to this state, which is kind of like private and local. So like there's no way anywhere in this code, right, that somebody can access next to-do ID. There's just no way that they can do that. Like if I wanted to show them what this variable is, I would have to like expose it here. Or if I wanted to allow them to set it, like set filter, I would have to allow them or give them something like a setter. But other than that, this is like completely internal, and it kind of creates a abstraction that is similar to like as if this was a class and this was a field and it was private, and then I had like set of getters for it, right? And so we're actually very close. In a video or two, we're going to get into start like refactoring the app so that it adheres to object-oriented programming. But this is one of the closest way that you can mimic that idea of working with functional programming paradigm.